Okay, so we've talked about specific heat and exactly what it is. So now we're going to do the mathematical part. And if you look at the formula up here, we've got Cp equals Q divided by M times delta T. Now Cp seems kind of like an odd variable, but it really stands for specific heat capacity. If it was my world, I'd make it an S, but it's a C, and so that's what's going on. This little bitty P right here just stands for standard pressure, which is beyond us, but it's what they usually put. So Q is our heat, and if you look at the variables down here, it's our heat energy, and the unit for heat energy is in joules, so we'll measure that in joules. M you're familiar with, that's the mass. We measure that in grams or kilograms. And then temperature, notice there's this triangle here, and what the triangle is telling us, it's a change. So there's going to be some initial temperature and some final temperature. So that delta T really means T final minus T initial. So there you go. And so there are all the variables. Now with temperature, we can have it in Celsius or Kelvin. It doesn't matter. Either scale is fine. And then look at this funky unit right here for specific heat. Joules per gram degree Celsius. Now it looks funny, but when you see the calculation, you'll understand why. So let's say we had a piece of metal, and it weighed 4 grams, and we put in 32.0 joules of energy, and the metal went from 31 degrees up to 40 degrees. So with our calculator, we would take 4 times the difference there, which is 9, times 9, and divide that into 32. And then we get this unit. Now look at what happens to the units. Grams doesn't cancel out of J, and C doesn't cancel out of J, and G times C doesn't cancel out. So that's why we get this unit joules per gram degree Celsius. Okay? So those are all the variables, and that's the formula we're going to use. Now you might be wondering, wow, I really like the density pyramid. Can I have a specific heat pyramid? Well, here we go. Q's on top, and then it would look like this. C, M, delta, pretend that's a triangle, delta T. So there it is, the specific heat pyramid. Alright, so for those of you that don't like to convert units, not convert units, but rearrange the equation, use that. It works just fine. Okay, so let's try a couple problems. Here's our first problem. We've got a specific heat. We want to find the specific heat of a 25 gram piece of metal that has a change in temperature from 22 to 29, and then look at the units we're putting in for joules. Okay, so we're going to solve for specific heat. So I like to write the formula out first. So C equals Q over M times delta T, and then let's plug them in. Okay, Q is our energy in joules. That's this value over here. So I'm going 32.50 joules. Okay, and then my mass is right up there. Now you might wonder, well, how do I know that's the mass? Well, look at the unit. It's in grams, so that's what tells us. Okay, so 25.0 grams, and we're going to multiply that by the difference between these two temperatures. So the initial temperature, or the final temperature, is 22.9 degrees Celsius, and the initial temperature is 22.0 degrees Celsius. Okay, so you can do this in your calculator all in one step. Do the bottom first and then divide it into the top. So when you work that problem out, your calculator says 0.1646, and then our unit is, of course, joules per gram degree Celsius. That's the units for specific heat. You may have memorized it, or just look at these units right here. Nothing cancels. Now, you might notice that there's only 3 significant figures in a bunch of these numbers, so really, we should round this to 3, so that would make the answer 1.65. Okay, so there you go. Now I'm going to put up another one, and what I want you to do is pause the video and try it and see if you can do it. And then if you did, you'll see me try it, and if not, we'll see if the way I do it makes sense to you. So let me get this problem out of the way. Okay, here comes number 2. Okay, so look at number 2. So read that question, pause the video right now, and give this a try. Okay, did you do it? I hope you did. Let's look at what they want us to find. They want us to find how many joules of energy. Okay, so joules is our variable for energy. Or pardon me, that joules is our unit for energy, and energy is Q. So let's write out the formula. We're going to be solving this problem. Q equals C times M times delta T. Okay, so now that we have the formula written out correctly, it's just a matter of plugging it in. What's the specific heat of water? Well, there it is, 4.184 joules per gram degree Celsius. Okay, times the mass. What's the mass? We were looking for grams. There's our grams. Okay, so it's 30.0 grams times the temperature change. We're going to put the big number first. Okay, so it finished at 100 degrees Celsius and went and started at 40 degrees Celsius. Okay, so when you multiply those three numbers together, you get 7,531.2 joules. Now, if we look at our significant figures, we've got 4 there, we've got 3 there, we've got 3 there, so we've got to round this to 3 digits. So let's go 7,530 joules. All right. Now, that number might seem like a big number, but we're talking about energy, and it's pretty typical to see that value in the thousands. Okay. So hopefully you got that one. Now, if you did, great. If you didn't, we're going to try another one. You'll get another chance. So let's do the third problem here. And again, I'll put this up, pause the video, try it, see if you can do it. And if you get it, great. And if not, try and follow how I did it. Again, we're going to do the same thing. We're going to rearrange the equation so that the variable we're solving for is on the left and everything is on the right. So let's look at this problem here. How much does this piece weigh? Okay. Hopefully you go, oh, I need to solve for mass. So whether you use the density pyramid or not, let's look at this. If I cover up mass, what do I have? I have Q on top divided by C times delta T. Okay. So M equals Q on top times C times delta T. Now another, maybe an even easier way to remember these rather than using the pyramid is that if you're solving for any variable other than Q, Q is always on top, everything else is out on the bottom. So that might help you out also, just whatever works for you. So let's put in our numbers. We've got our formula written out correctly. There's our joules. Look at that, big number, just like last time. So hopefully that makes sense. So 5,260 joules. All right. And let's see, where's the specific heat? Look at that funky unit, joules per gram degree Celsius. Even if you don't know what the numbers are, look for the unit and that'll tell you. So I'm going to put 0.449 joules per gram degree Celsius. Okay. And then I'm looking for my temperature change. It ends up, the final is 35.3 degrees Celsius minus 20.0 degrees Celsius. Okay. So subtract that, it gives you 15.3 times it by 0.449, divide that quantity into 5,260, and let's look at our units. Joules right there cancels that joules. Celsius cancels out that Celsius, and we're left with grams on the bottom of the bottom, which means it's a reciprocal, so it's on top. So with that number, we get 765.7 grams. Okay? But you're saying, well, no, we need 3 significant figures, I hope. So we're going to round this to 3 significant figures, 766 grams. And that would be your final answer. So now you're saying, man, this is easy stuff. I like these problems, right? Well, let's try one more just to make sure. And let me move this problem. Okay, there's that. Take number 4. Okay, read that for a moment, pause the video, give it a shot, see if you can get it. Okay, if we look at the problem, look at what variable we're solving for. We're solving for temperature. Okay, if I come back to the density pyramid, I'm going to cover up delta T. What's the formula? Q on top divided by C times M. Okay, So write it out. Now, if your math teachers don't like you to do it this way, you can do it their way, but I find that I make a lot fewer mistakes if I rearrange the equation first. So delta T equals Q on top, C times M. Okay, so now we've got that written out. Now let's just plug in the numbers. We know that Q is energy, and energy is in joules, so there's our value right there, 3,950 joules, divided by, let's find the specific heat. Look for that funky unit. There it is right there. So our number is 0.8997 joules per gram degrees Celsius. And we're going to multiply that by the mass. So we're looking for grams. Okay, so 50.6 grams. Okay, multiply those two numbers together, divide them into joules. Let's look what happens to our units. Joules on bottom, joules on top, that cancels. Grams on bottom, grams on top, cancels. Celsius is on the bottom of the bottom, it's a reciprocal, so it comes on top. So, work that out. What do we get? 87.0 degrees Celsius. Final answer. Okay? So hopefully you kind of understand how this is done. If you don't, please come see me. I've got lots of these we can practice. And the more you do of these, the easier they're going to get. And stop by and see me if you need any help. Hopefully it all makes sense.